Okay, so hello everyone. It's great to be at RomHack. Today we are excited to share how we managed to steal PRT cookies on macOS. And then we will use those cookies to achieve persistence in Entra ID. And quick spoiler, we actually found that Microsoft's implementation on macOS is more secure than their own approach on Windows, and which is pretty interesting. And also, we have two speakers today, and I'll be starting first. My name is Kazma Ye, and feel free to just call me Kazma. I'm a university student from Taiwan, and also I'm a CDF player. For the past few years, I've been leading a pretty active team called Beef Soup, and we've managed to bring home quite a few trophies along the way. Recently, I'm just transitioned from intern to cybersecurity researcher at Cycrypt Technology. So I'm still learning a lot every day, and I'm really excited to be here at RomHack. So before we dive into this attack, let's first set the stage. Microsoft offers a huge number of services. If you just do a quick search, you'll find hundreds of products. And basically, you log into all of them using Entra ID, or we also call your Microsoft account. And here's the problem. If you don't want your computer to ask for your password again and again, the operating system has to integrate with Entra ID. And let's start with how this works on Windows. On Windows, that's a process called LSAS. And this process handles authentication. And inside LSAS, there's a plugin that interacts with the TPM, the Trusted Platform Module. And these hardware devices are designed to store like private keys securely, and making sure that they never leave the computer. And in this setup, two important things are stored in the TPM. The first one is the PRT, which is the primary reference token. And this PRT represents your user identity. And the second is the session key, which represents your device identity. And the key point is that these two things never leave the device. And the PRT stored in the TPM can be used to create a PRT cookie. And that cookie is valid for about 15 minutes. And within that time, you need to exchange it for a reverse token or an SS token. And with those tokens, you can access the services you needed. And by combining this process with the TPM, Microsoft ensures that you're always coming from a managed device. OK, so how does this tie into the browser? When you log in, the browser first gets a nonce from the Entra ID. And this nonce is then passed to the BrowserCore, which calculates the PRT cookie for you and send it back to the browser. And this Windows flow has been studied quite a lot already. In short, there are at least 3 ways attackers can abuse this process and obtain a PRT cookie. And interesting is that none of them have been fixed, and they remain effective even now. And here's a detail that often get overlooked is that after the device register with Entra ID, the PRT and session key are saved inside the TPM. And they don't get transmitted anywhere. They just sit there waiting to be used in later calculation. And the problem is, if an attacker gets even temporarily access to a company-managed device, say one enrolled in Intune, they can still use the TPM as a black box to generate the values they needed. And that's enough to impersonate both the user and the device identity. And why does this matter so much? Because a PRT cookie from a trusted device contains both an MFA claim and a device claim. In other words, by holding this cookie, you're essentially telling Entra ID that I'm on a trusted device and I'm already past the MFA. And that's exactly what makes stealing PRT cookies so valuable. OK, now let's move into the world of Apple and start with one key question. Why do we steal macOS PRT cookies? Today, many organizations rely on Intune as their MDM solution for both Windows and macOS. And with conditional access now extending to macOS, zero trust policy is no longer just a Windows story. And here's the catch. Most research and detection still focus on the Windows, while macOS remains largely unexplored. And that's why we decided to dig deeper into how macOS handles PRT cookies And more importantly, where's the Winix? So where do we begin on macOS? If we want to steal the macOS PRT cookie, we must enroll our device into Entra ID. And according to Microsoft official documentation, we need to download and use in this company portal app. And the company portal app has two main roles. On the left, you can see its Intune-related features for device management. But what we really care about is on the right, where macOS apps and even Safari go through its SSO extension whenever they need to perform the single sign-on. And let's dig a little deeper into the company portal's internals. Inside, we can see two main plugins, and one is the macOS SSO extension. This is the one we just mentioned. And the others start with autofill, which we won't cover today because it's not related to SSO part. And next, under the macOS SSO extension, there's a framework called AD Authentication Broker macOS. And this framework is responsible for most of the validation checks. And on macOS, a framework is similar to a DLL on Windows. Both provide libraries, but a framework is usually contains additional bundle resources. Conceptually, though, it's the same idea. And finally, under the resources folder, we also see BrowserCore, which should sound familiar from the Windows flow earlier. In the Windows SSO flow, BrowserCore plays a key role in handling SSO requests from the Google Chrome. So when we notice that company portal also contains a component called BrowserCore, we immediately suspect it might serve a similar purpose and possibly help us get access to the PRT cookie. And to illustrate this better, I put together macOS SSO flow diagram inspired by this Windows one. From the diagram, we can see that macOS provides an AppSSOAgent to handle requests from different vendors. And unlike Windows, macOS doesn't have LSASS. So here, the macOS SSO extension inside company portal is responsible for computing the final PRT cookie. And at the same time, any request passed into the company portal will also go through the AD authentication framework, which validates whether the caller is legitimate or not. Now that we map out the macOS ecosystem, let's move forward. Next, I'll walk you through three different methods we found to steal the PRT cookie on macOS and explain how they work. So let's begin with the first one, is headless browser-based native message abuse. This first method is actually quite straightforward because Microsoft provides us a Microsoft SSO Chrome extension, which allowed us to initiate an SSO request and directly retrieve the output. On a compromised macOS device, we can simply install this extension and extract the PRT cookie right away. From the logs, we can also see that the component handling this request is BrowserCore. So confirming that, just like on Windows, BrowserCore also plays a key role in the SSO flow on macOS. But this approach does come with a few limitations. First, running a headless browser still need us to request the victim to be logged into their desktop session. Because headless doesn't mean no GUI, it's more like a transparent browser running in the background. And second, this technique only works with the official Chrome and Edge browsers. And we'll understand why when we get to the third method. So the first method works, but it comes with some specific dependencies. And naturally, we weren't satisfied with just that, which brings us to the second method, bypass BrowserCore's parent process check. And after some reverse engineering, we found that BrowserCore first calls this running application with process identifier function to get the parent process info. And then it runs cosine-dv command to grab the team ID and the bundle ID. And these two values are concatenate, hash, and check against an internal whitelist. And here's the fun part. Much later in our research, we realized that this running application function only works with the app process. So later you'll see our POC will package into the application format. Now, you might notice two terms here that sound a bit unfamiliar, is team ID and bundle ID. And let me break them down quickly. Team ID is an identifier included in the certificate issued by Apple to each developer. So only the developer who owns the certificate can sign the app with their own Team ID. But bundle ID, on the other hand, is just a string for identifying the app. It has no real security value, and we can change it to whatever we want. So in short, Team ID matters for security, but bundle ID doesn't. And on Windows, there's also something similar. It's called security identifier, or somebody call it SID. It works kind of like the bundle ID. It's just for identification for the app and has no real security value. And what's interesting is that Microsoft never implemented something like Team ID on their operating system. So checking this on the Windows flow is a bit pointless. And as you can see, this flow involves multiple components, and that means multiple coders. And more coders usually means more coder validation checks. So let's clear things up and focus on the two most important ones. The first is BrowserCore's coder, which, as the name suggests, is the browser. And that's also the parent in the parent process check we mentioned earlier. And you can see that we're talking about right here on the diagram. OK, so to wrap up the second attack method, first we create a payload binary. And since BrowserCore calls cosine-div command without absolutely pass, so to fetch the team ID and bundle ID. So we can abuse that by using pass interpretation. We drop a fake cosine binary in /tmp and change the environment variables. So BrowserCore runs our version instead of the real one. And this way, we can return any team ID and bundle ID we want to pass the whitelist check. And finally, we package the coder into a die process because BrowserCore needs to retrieve the parent process information since the ROM application function we mentioned earlier. And here's a screenshot of our POC. This execution is almost instant, so showing the video will be kind of funny. And we'll be releasing this POC script at the end. Now, before we wrap up the BrowserCore's bypass method, there's a little story here. At first, we tried patching BrowserCore and running it directly, but we ran into an issue. It's called caller is not allowed to invoke, along with an error code -6000. So after hitting that error, we used LLDB to see what was going on. And to our surprise, we just get the PRT cookie right here, and that made us to figure out what was going on. We noticed that the key difference in the logs that the fail run couldn't retrieve the team ID and bundle ID. And the component responsible for getting that information is AppSSOAgent. So we started reversing it. And here's the key point. When AppSSOAgent retrieves information like the team ID, it checks whether the coder is valid or running in debug mode. And this explains what happened earlier because when we patched BrowserCore, CS valid flag became false. And when we attach LLDB, CS debug was true. Some of you might be thinking, does that mean LLDB can also be a way to grab the PRT cookie? And exactly, we thought about that too. But here's the catch. We need to disable system integrated protection and then approve the developer to access prompt with our touch ID or password. So LLDB method requires us extra privilege escalation. Now, the coder we're talking about here is the second one. AppSSOAgent checks whether its coder has CS valid flag or CS debug. And in this case, the coder is BrowserCore, and which is what you see here on the diagram. So in short, the second method works, and it doesn't require any extra prerequest. And that little LLDB twist led us to dig into AD authentication framework. And what we found was the BrowserCore was just the tip of the iceberg. As we dug deeper, we discovered that there are actually 4 different SSL paths, and that led us to a third method, direct SSL code invocation via Apple's API. These 4 SSL paths are first, browser native message is the same route BrowserCore uses, and the second is passkey credential operation, which, as the name suggests, is for the passkey. And these 2 paths enforce team ID and bundle ID validations, But then we found there are two paths that don't validate the team ID at all. One is general SSO extension requests, mainly used by Microsoft apps like Outlook, Teams, and Excel. The other is cookie SSO acquisition, mainly used by third-party apps like Firefox or Opera. And we can see that in the cookie SSO flow, there's a whitelist of 16 bundle IDs, and coming from the third-party browser bundle IDs NS block. And the problem here is that this path doesn't validate the team ID of those third-party apps at all. So what that means is we can just direct code the verification path and attach any one of those 16 bundle IDs, and I'll be able to obtain the PRT cookie. And just as I said, we successfully get the PRT cookie right here. And also, this tool will be also releasing at the end. So to wrap up, the third method is also requires no extra prerequest. And just like the second one, it works entirely with user-level privilege. And before wrapping up this section, let me share a couple of interesting findings we came across during our research, and as well some of the biggest Microsoft made over this summer. The first one is about BrowserCore. Originally, Microsoft used a relative path when calling cosine command, which allowed us to perform a path interception attack. And in their fix, they replaced the relative path with an absolute one, and it makes sense. Next, Microsoft also improved their check against our direct SSO call attack. Previously, some third-party vendors only validated for the bundle IDs. So they adjust the whitelist and add verification of 4 additional team IDs, which is Prisma SS Browser, and also called Talon Browser. But since Talon Cybersecurity was acquired by Palo Alto Networks in December 2023, so Talon's team ID is different from Palo Alto Networks. So there's also another one for Palo Alto Networks, and there are also Firefox and Google Chrome. And indeed, when we reverse the third-party bundle IDs, we confirmed that they match those 4 team IDs. And on the slide, you can see how the bundle IDs can be grouped into these 4 categories, which we mentioned in the previous slide. And in addition, although most of our discovery highlighted weakness in Microsoft macOS implementation, Apple reached out to us before our Troopers talk in June. They proactively addressed some of the issues, and in macOS Ventura 13.7.7, you can even see a CV related to this research published. And some of you might wonder why Apple had to patch anything if the issues were in Microsoft implementation. And the reason is that in the macOS, as the operating system, it needs to handle requests from different vendors. So by adding more validation checks at the OS level, Apple can make the overall environment safer and reduce the chances to mistake by third-party vendors' implementations. So many thanks to Apple by doing this patch. And here's something a bit more fun upon doing reversing. When we look into the binary, we actually found traces of the developer's environment. Things like their username or report or the path name. Because in Objective-C, login macros like nslog or msid logger automatically embed constants such as file name and path into the binary. And even if you strip the binary, these strings stay there unless you change the compiler settings or redefine the macros. So out of curiosity, I copied the usernames and searched online, and I found a LinkedIn profile of a Microsoft software engineer with these matching skills. Yeah, you can see that it's about Mac, Xcode, and iOS development. So this is quite interesting. OK, so let's back to the topic. In this section, we've shown that stealing the PRT cookie on macOS is indeed possible. But once you had the cookie, you only have 15 minutes. So the question is, how can we turn that into persistent?
OK, thanks, Kazma. So next part, I will introduce how we achieve persistence in Entra ID. So we already just introduced ourselves. I'm John, and so I'm a degree director of research at SciCraft, which is Taiwan cybersecurity company. And also, I am a big fan of punks, so our cybersecurity company, UCCU, actually is punks. And also my blog, Hacker Peanuts John, is also the punks in Mandarin. And there's another key member in our project is Dongling Li. Yeah, you might notice I'm John and Kazma. Every Taiwanese working in IT, they all have their English name. So there's a key. The Entra ID persistent parameter is me and Dongling Li made it. So jumping to our topic, because the PRT cookie only validates a few minutes, so we want to achieve persistence. But how? So we can be using the device join scenario. Like you can use a fake device and use this fake device and generate the PRT cookie. And even more, you can bypass some conditional access policy. But there's some requirement is, if you're trying to register a device, you need an access token without device claim. Which means if you're trying to steal the PRT cookie from a device, you cannot use just the PRT cookie to register a new device. So we will introduce later on about how to bypass it. And besides more, we are not just register a fake device persistent in Entra ID. We also want to bypass some conditional policy, like the MFA. And there's some interesting knowledge about the MFA is if you log in through the passwordless authentication, Microsoft will just give you the MFA claim. Even you didn't actually pass the MFA, it will just give you the MFA claim. And if you're trying to register Windows out of this device, you require an NGC MFA claim. What's an NGC MFA claim? Which is indicated you passed the MFA in the 10 minutes ago. Besides the MFA, we also want can bypass some conditional policy like a required device to mark as compliant. In this part, you can use a Pine tool to help you to achieve that. So here is our whole persistence flow. We have the 5 steps. For the step 3 and step 5, register fake device and register Windows Hello for Business, you can use a tool called Raw AD Tools. So it's published by Dr. Yang. And the step 4, make a fake device, pass a device compliance, you can use a Pine tool. So there is coming a key question is step 1 and step 2. So this cannot be achieved now, so we will introduce how we achieve the step 1 and step 2. But before we dive in step 1 and step 2, like the get token without device ID, actually previously you can use the stolen PRT cookie to register a fake device. And also you can transfer the MFA claim to the PRT. There's a lot of relay issue. Microsoft already fixed it. If you are interested about the relay issue, you can check about Dr. Yang's blog. All the relay issue he found out. So in step 1, we need to get a token without device ID because we need to register a fake device. So how we get the token? We have a lot of methods, like you can use in phishing. The upside is you don't need to really compromise the endpoint. But the downside is you need to some user intention, and it's not reliable. And also, you can use a seamless single sign-on. It's a setting enabled on your Entra ID tenant. The upside is the noise level is very low, but the downside is based on our research and Dr. Nastori, he will talk later on. In the 3 years ago, around the 25% of the tenant has this setting enabled. It's not too much. And the third method is reset password. The upside is you across the different OS and the join type. The downside is user might notice the password has been changed. So we will talk about this part later. So how to reset password? We will need login to Microsoft My Sign portal. There's a front end and back end logic. If you log in with the access token with the password claim and the multi-factor claim, the UI will say, hey, you just need to type your new password. and which is mapping to the API password reset endpoint. But if you log in with the access token only MFA claim, just like you stealing a PRT cookie, you only have the MFA claim. The UI will say, hey, you need to type your current password. And this mapping to the API password change. So which would be great if we can abuse the API password reset. So here is kind of inconsistent logic. So between the front end and back end, if you're trying to call in the API password reset endpoint, actually the UI says you need to password claim, but actually you just send the MFA claim. The password claim is not required. So we can easily to abuse this inconsistent backend and the front end. We can just call this endpoint and reset the current password with a stolen PRT cookie from a device. So later on we will give you a demo. And the default method is to use a passkey in a Microsoft Authenticator. The upside is the noise level is very low, and you can get the token without device ID. Also, you got the MFA. But the downside, you require some user interaction, so you need to pull out your phone and press enter. So once we get the access token without device ID, we still need to find a way to re-authenticate MFA. We want to get the NGC MFA claim because we want our fake device to upgrade to Windows Server for business device. So basically, if we're trying to get the NGC MFA, we need to pass the MFA in the 10 minutes. So for the scenario is we store a PRT cookie, so we only have the MFA claim. So if we want to upgrade to NGC MFA claim, so we need to pass the MFA. But how we bypass this? We don't have MFA. But that's the interesting part is, if we're trying to register a new MFA method, you only have MFA claim, right? So register a new MFA is okay for Microsoft. So you don't need to re-authenticate MFA. So we can register a new MFA method in the Fitton's account and bypass it. So it's just like NGC MFA protection, just like that. Yeah. So for Microsoft, you are previous Microsoft just feel like you use a stolen device credential to register a fake device is not allowed. But if you manipulate authentication information and register new device, it's okay for them. Yeah. But later on I will say how MSRC respond us, how they fix it. And here is our demonstration. We will compromise macOS and steal the PRT cookie from macOS and register the fake device and adding the own MFA and add to make our fake device to a Windows Server for business device. So first, we are just trying to access the conditional access policy and just check our Fitton has required the OMFA to the AppSSOAgent all resource. And then we are trying to steal the PRT cookie from the Fitton's account. And then we just stealing the PRT cookie from macOS. Now we have a PRT cookie. Now just for the proof, so this PRT cookie only have RSA claim and the MFA claim. So we don't have the password claim and the NGC MFA claim. So we are use our own script to reset the Fitton's password. And then we have control the Fitton's password. And now we are just trying to log in to register a fake device for later move persistence. And now because we already reset it, so we are trying to open the Office 365 portal. Just proof we have a successful control of Fitton's password. And now typing the new password, and they require the MFA. But we don't have the MFA yet, so Again, we are still in the PRT cookie. And use this PRT cookie open the My Sign-in portal. And just for easy demonstration, so we are using the browser to easy to understand how to achieve that. So we're just adding our MFA method. So in this part, we use key pass with a TOTP code. So for easy understand. So just copy the seed and pass in the key pass. And then we got the OTP code, so we just successfully register the TOTP MFA. And now we want to our current access token to upgrade to a NGC MFA client. So now we use the root tool, and it will pop out Windows, and we just enter our TOTP code. And now we have NGC MFA client. So now, once we have NGC MFA client, so we can upgrade our fake device to the Windows Allow for Business device. And now we have successfully registered Windows Allow for Business device, and we can use a Windows Allow for Business device to log into the Office 365 portal. And also, in the Fitness account, if you check on the authentication method, you will notice there's a Windows Allow for Business device. That's we just added in the Fitness account. Yeah, that's all demo. Thanks. So based on the demonstration, there's a 3 key elements. All this element is coming from the fake device. We have a user identity, we have a PRT, and we have very strong MFA, the Windows Allow for Business. So we have these 3 items we can persistent in the Entra ID. And not just in Entra ID. If you have the PRT, actually, you can lateral movement between the Entra ID joint device. So you can use in this year, in the Troopers, there's a talk about how to use a PRT lateral movement between the Entra ID joint device. You can check, if you are interested about this part, you can check on that. And then you might be thinking, oh, what if I require all of things like a registered device or the registered secure information all of things need MFA. You can implement this, but you will encounter some problem, and it's actually not working. And also, if you implement this kind of conditionalized policy, you might encounter deadlock. Like my friend, he just implemented this policy, and they have new employee on board, and they just type a password. And the Entra ID say, hey, you need pass MFA, then you can enter MFA. But he's just new in this company, so he didn't have MFA. So you will encounter something like this deadlock scenario. The only way to escape out is to use a tab for the initial login. If you apply this conditional access policy, it's not enough. So just use this diagram to easy to understand. So you have the PRT cookie with the MFA claim. And then we have 2 methods to do. First is adding the new MFA. The current conditional access policy just requires you, hey, you need to pass MFA, but we already have MFA claim, so we can easily to satisfy this policy check. And then follow reset password. Because the UI, front end, and the back end, they are inconsistent. So we can easily to reset the current password. And now we have our own MFA, and we have a successful reset the fitness password. So now we can register our fake device in the Entra ID tenant. But there's a conditional policy require MFA for the registered device. But we have our own MFA, so we can easily satisfy this policy check too. And then we can upgrade to our fake device to a Windows Allow for Business device because we have TOTP, our own MFA. So we can persistence in Entra ID. Just like Kazma mentioned for the macOS PRT cookie thief, Microsoft already fixed it. So you just update your company portal. And besides of just fix it, and we also want to mention, because Intune has a wide list of bundle ID, you still need to check the Intune app preferred allow list and the app cookie SSO allow list in your organization setting. Because if it is a wide list, it still be possible to abuse it. And here is a summary of our talk. Now, PRT cookie on macOS is now possible. And also, we noticed not just Microsoft, other vendors has implemented the SSO extension on the macOS. We think they might have a similar issue. And also, if you are the macOS developer, always use the team ID, not the bundle ID, to check the binary. We have a presentation about this part in a DEF CON, and MSRC respond us they will start to fix it, but until the last Friday I tried is a persistent method, it's still working. So maybe they want to let us have some fun, just play it. And also, if you want to mitigate the persistent method, actually you can create a conditionalist policy with some weak criteria like the IP, location, user agent. It still can make the attack very hard to persistence. And also, you can monitor the new join device and the user adding the new MFA. You can monitor it and check with your user. And that's all. And here is the GitHub repo. If you are interested about how to steal the PRT cookie on macOS, you can check it on this GitHub repo. And thank you.
Okay, thank you very much. So we have one question from the people at home or here. We will never know. Okay, great talk. I didn't get or understand how you mimic the Chrome signature. Isn't the point of a signature that you cannot fake it?
Oh.
Because the BrowserCore method, BrowserCore only use cosine -db command to retrieve the team ID from the terminal output. So this is not like the authentication framework check for the team ID, because BrowserCore only use cosine -db command to retrieve team ID. So we can actually write our like Google Chrome's team ID and bundle ID to the terminal's output and use our cosine command to retrieve that. Does that help?
Yeah, I think so. Thank you. Yeah. Okay, another round of applause for Shang-De and Kazma.